You've connected to Cisco Unplugged.
Hello, everyone, and welcome to Cisco Unplugged. I'm Dan Klamert, your host. I hope everyone is staying warm here in the polar vortex. And this week on episode 49, we're going to be discussing unlocking IoT potential with Cisco's ultra reliable wireless backhaul, or CURWB, as we like to call it. So I would like to welcome to the show today, Igor Moiseev. Hey, Igor, how are you doing today?
Doing well, Dan. Thanks for having me on Unplugged.
Thanks a lot for joining. Appreciate it. And then I'd also like to welcome back Al Dumdai. How are you doing, Al?
Hey, good. Thanks, Dan. Surviving the polar vortex.
Yes, hang in there. Thanks for joining. So before we get started here, just a couple reminders. We do take questions live via Slido. So you'll see those QR codes on the screen. You can join there. We also have the link on the YouTube channel below the video. You can click on that link, join the Slido, submit any questions, and we'll jump in and ask those live during the episode today here. And as usual, we are recording this episode. It will be available on our YouTube channel, unplugged.com. I'm sorry, youtube.com/getunplugged. And when you go out there, please, if you haven't subscribed, like the channel, you will be then notified when we do go live. You turn on notifications with more great episodes and content ahead. So before we get started, I do want to say that we do have a two-part episode today. We're breaking this up, so stay tuned for next episode. Episode 50 will be the exciting conclusion of this episode with Igor. But just wanted to put a plug in for that this will be a two-part episode here. So, all right, I think that's it for the reminders. Let's get unplugged here. Igor, you want to take it away?
Sure. Thank you, Dan. So let's jump into part one. Okay. So hello, everyone. My name is Igor Moiseev. I'm an IoT Wireless SE, and today we're going to get a little bit deeper with ultra-reliable wireless backhaul. Today, we're going to have a packed agenda. We're going to talk about these topics here. So kind of a quick recap, talk about the service and monitoring tools, and then also some common static and mobile architectures that we're seeing, and then finish everything up with a quick demo of Fluidity and IW Monitor. So let's get started.
Hey, and Igor, real quick, sorry, I did neglect to mention, this is building off of previous episodes. We have covered ultra reliable wireless backhaul on previous episodes. I think episode 15 was one of them. It was a very popular episode. We had a lot of views on that. So we wanted to kind of dig deeper here. And I won't steal all your thunder, but part two, super excited for that as well. But just wanted to let everyone know, our viewers, this isn't a rerun.
Maybe one other quick comment, Dan. I was talking to Igor before we started. He's been doing this since like 2010, 2011. This has been his kind of sole focus for, 15 years plus, right? So Igor's got a tremendous amount of experience. I mean, we all kind of dabble in this. A lot of us have dabbled in this. Igor lives this, right? And he has lived this for 15 years. So really privileged to have, his experience here. So looking forward to this.
Yeah, definitely. Thanks, Igor. Didn't mean to.
Yeah. Okay, guys. Thanks for the kind words, Al and Dan. Awesome. Yeah, let's get started. So kind of a quick recap. So what is URWB, aka Fluid Mesh? So it stands for Ultra Reliable Wireless Backhaul. So reliable wireless anywhere. And the two common, architectures are static and mobile connectivity. So static is your point-to-point, point-to-multipoint mixed connectivity. For IoT, this could be interconnecting DOT traffic cabinets, could be interconnecting utility substations back to the main office, or it could be extending your manufacturing IT network outside to the outdoor space, that guard shack, that perimeter security. And then you have mobility. So make before break, high throughput, low latency, 0 millisecond roaming is another great thing that we do with URWB. And for IoT, this is connecting to AGVs at manufacturing floors, dozers and open pit mines, ship to shore cranes, and then trains for your transportation commuter rail type of networks. High level, it's a very flexible technology. It's more of a build your own wireless architecture. And these are more or less the common architectures that we see throughout our IoT verticals. So when we're talking static, we're talking kind of set and forget from an RF standpoint, a steady state RSSI. And we're going to be talking about fixed and fluid max, the two configuration modes that you can easily configure these architectures into. And then there's mobility. You have a fixed infrastructure, but a moving vehicle. And that's where we want to kind of switch gears and look at a different architecture with fluidity. And we'll talk about this later on in the slides. So what makes ultra reliable wireless backhaul reliable? So a couple of key ingredients. The first is the protocol itself. So it isn't 802.11 based. It's actually MPLS based, and we call it Prodigy 2.0. And that's what allows us for the low latency connectivity, and also sets the foundation for high speed mobility, enabling that 0 millisecond handoff, and also fast failover. There's a couple different ways we can address failover. We can either build with it with HA, we can do it with Fluid Max Auto Scan, and from a fluidity standpoint, you can have multiple frequencies off your vehicle and also enable something called MPO. So quick shout out to episode 15. Our colleagues, Dan and Ray, did a great job kind of setting the foundation for this episode. So definitely check that out if you want any more information on some of this technology. So today, the URWB technology lives on the Cisco Industrial Wireless portfolio. So you can see here our family photo of IW9160 series APs. And today, CURWB lives on these products, and I kind of think of it as a software-defined radio, because that 9160 AP, you can change it from URW mode or workgroup bridge or Wi-Fi, CAPWAP. So it truly is a software-defined radio that you can more or less change in software from one mode to the other. And unfortunately, URWB is not on every AP. Some APs are more traditional stadium Wi-Fi APs or omnidirectional APs. So I've kind of highlighted the supported access points where you can run your static and mobile CURWB architectures. In high level, these are all outdoor rated IP67, low and high temp specs, and also high humidity. So they're more or less purpose built for these outdoor rugged IoT environments that we're used to deploying into. Okay, so before we jump in, let's pause and reflect on how we came to where we are today. So believe it or not, Fluid Mesh, now ultra reliable wireless backhaul, just reached its 20th year anniversary. So they were co-founded in January of 2005 by 4 Italian engineers and entrepreneurs. And I'm super excited to kind of show you the evolution and progression of FM to now IW radios. And now I'm going to kind of show you a few installs that you see. So fortunately for us, IoT Wireless really can't hide, because a good install has good vertical assets, good line of sight. So they're pretty easy to spot out in the wild, as we like to say. So here's a great example of a currently running point-to-multipoint network using some of our original products like the 1100 and 3100 MITO series. So here's kind of a common point-to-multipoint architecture, great line of sight, and the application here is backhauling cameras and LCD LED signage, for example. Some other examples here, so longer distance, dish-like antennas to get you that extra gain. And think of URWB as an Ethernet backhaul. So you could run 2 point-to-points in parallel and have the redundancy running on the switching side, either with spanning tree or some other layer 2 loop prevention protocol. And then another example on the right-hand side for a standard 1 mile urban shot point-to-point. So these are all very realistic installs. And I just want to kind of show you and highlight the ultra reliable portion of URWB. So these have been.
You know, the one on the left, what is the range on that? It looks like it's pretty far off.
Yeah, so that one's going about 5 to 6 miles.
Okay, all right.
So it might be a little overkill.
Is there a range where you sort of think of, okay, this is kind of the sweet spot, or works in, you know, if it goes beyond this, we probably don't want to consider using this, use something, high power microwave or whatever, is there sort of a sweet spot for this?
Yeah. So based on our portfolio, what we sell at Cisco, antennas and hardware, I would say that sweet spot is in the under 5 mile range.
Okay.
We
Perfect.
can go further, but that's where we need to kind of engage with a specialized partner and potentially a third party antenna.
Gotcha. Okay. Perfect. Thank you.
But yeah, as you guys know, your mileage may vary with wireless. And at the end of the day, it's kind of an engineered solution, making sure you're hitting the distance at your RSSI. And then once you do that, your performance, your throughput and latency will follow. So just some kind of good examples of installs we've seen over the years. And another application here. So IoT, this is for a rail customer here. So they're using ultra reliable wireless backhaul to backhaul cameras off of the track. And they're using these cameras to do OCR and read the letters and numbers on the trains as they're coming in. So further prepping the operations crew at the yard and also understanding where a certain product is going to. So just some examples there. And then kind of evolving off of that 11 and 3100 series, we had the 1200 and 32. So here's another common example we see in our extended enterprise vertical. So extending off of that IT carpeted space into the outdoor world. So here we're just providing wireless backhaul to cameras and Wi-Fi APs in a park area outside a convention center. So it's a lot easier to set up a wireless backhaul than say try to trench or route a fiber from that cabinet. So all you need is a couple of vertical assets and line of sight to make it happen. So there's another point to multipoint example there. And then another common example we see in our state DOTs. So networking disconnected traffic cabinets and cameras on the light poles. So more or less a daisy chain point to point, maybe doing a 1/10 or a 1/4 mile at a time, and eventually offloading to that wired Ethernet connection at the core. So just some examples of what we see out in the field, that vertical horizontal separation, and some of our legacy products, which we're going to still meet that same use case with our current product. So for those customers still using FM, they're upgrading to our 9167 and 65 series. So they're expanding, they're upgrading with our new portfolio here. So just some common installs there for point to multipoint off of that vertical asset for a DOT-like application. And then shifting gears, what we saw previously was more static configuration. With our fluidity, our mobility, here's kind of a common design approach that we see in manufacturing. So putting coverage APs or infrastructure APs every 150 to 200 feet, making sure you have good RF overlapping coverage. And you can kind of see here the evolution of our 4500 product and then shifting to our 9167 now. So RF, it's going to be similar, but just the radio itself, we're going to be using that newer 9160 series access point. So for all those customers currently using FM, I'm sure you've gotten multiple emails from our product management team about the end of sale announcement and also our migration strategy. So high level, we're going to be migrating old product like the FM series to the IW series. So they are backwards, forwards compatible, but there are a couple caveats, especially for the fluidity side. So that mesh end, that core device must be a new radio or an IEC gateway. And then from a vehicle standpoint, making sure you're not mixing and matching platforms. So either pick all FM or all IW, and you should be good to go from a configuration standpoint. But this is more or less what we're leaning towards. So we're going to the IW series and IEC 6400 versus our 200, 500 series and FM 1K, 10Ks as your gateway.
Igor, let me just double click on that just for a second. So if I'm migrating from fluid mesh to the IW, what are the things that I need to, what's kind of your strategy for something like that? Because it sounds like I can't mix and match. What are your thoughts around the migration strategy?
Sure. To be honest, it's more or less understanding your assets that are currently deployed, maybe coming up with a cutover plan. If you're going from old to new product, you're probably in a brownfield deployment. So you have to look for shut down windows and cut over windows that you can rip and replace, and also test that it's working.
Okay, but I need to replace kind of both endpoints. And if it's a point to multi-point, all the endpoints kind of at the same time, more or less. Is that correct?
Not necessarily.
Okay.
So you can mix and match, but it really just depends on how complicated is the current install and also the gateways. So for the larger fluidity networks, they're probably running FM 1 or 10Ks at the core. I would start with maybe understanding how to upgrade, because as soon as you put an IW into the field, you're going to have to upgrade that core gateway for the fluidity networks.
Okay. Gotcha. Okay. Thanks.
Yep. Yeah, I guess the best practice I could give is document, come up with a solid cutover plan, and also test and prep in the lab before you go out in the field and potentially affect production downtime.
Gotcha.
Yep. And just kind of a quick tech spec comparison. So IW versus FM. So on the right-hand side, our FM products were single radio and built upon .11n chipsets, and also limited to 2x2 MIMO. So now when you look at our new products now, the 65, 67, these are dual and tri-radio. So you're already doubling the amount of radios you can support off that one device. And also that enhancement to AX. So you're getting better data rates, wider channel widths, and also 4x4 when you're looking at the 9167. So you have a lot of multipliers in terms of throughput potential. But nonetheless, you can replace 2 Volos with one of these radios in the field. So sometimes there is a cost savings depending on your architecture and what you're trying to replace it with. Okay, so that was kind of a quick recap, looking at the IW products and also the migration strategy. Now let's look at how you want to configuration and monitor your devices. So let's look into the next 2 products. So the first one is going to be Industrial Wireless Service. So this is a cloud managed configuration tool that you can manage your devices in an online managed state or an offline mode. So depending on how your customer wants to deploy the network, they can do it in both types of modes. And now it's going to support both IW and FM. So as long as your fluid mesh devices are up to the latest firmware to run with IW service, you should be able to configure both IW and FM through this management platform. So you can see here, we're going to configure all the radios and the gateway using this service. Now, I would highly recommend using it because you have a single pane of glass, and you can also share your configurations with other folks, your maintainers, your admins, the guys who are going to maintain the system for the lifetime of the project. And there's a quick QR code in the top right. So if you guys haven't signed up for it, take a picture of that, and I'll go to the US cluster for IW service. So you can create an account and start importing your configs and managing your networks that way. And then just a couple more screenshots. So for those of you familiar with the Fluid Mesh product line, you were probably using Racer for plugin activation and configuration management. So IW service is more or less the evolution of FM Racer. So different format, but now you can manage both your IW and FM devices in both that online or offline mode. So you're not kind of stuck with one or the other. And in terms of management paths, so like any other network or Cisco device, there's a couple ways to manage it. You could start with local management, so doing one by one, going through the web interface or CLI. Or what we would recommend is using that IW service, either offline or cloud managed. So for example, in that offline mode, you would use your laptop connected to IW service. You'll import all of your radio profiles, and then you'll start configuring those radios to a certain frequency, passphrase, IP address, host name. And then you would download one file and then upload it to each device in the field. And that's what we're calling an offline managed mode. And then your cloud managed is, as it sounds, you're using the cloud. You have your radios that are internet connected to the cloud. And once you have a final config, you would push down the config and also firmware onto the device. So these are more or less the 3 different ways to manage your devices here. And then from a monitoring standpoint, we have something called IW Monitor. So this is a Docker container that's more or less a diagnostic tool for our radio network, and it supports both IW and FM devices. And for those highly moving vehicles, that fluidity architecture, we can sample those up to 3 times a second. So for something that's moving more often than a static environment, you want to sample the RF, the KPIs, the link error, packet error. So that way, if there ever is a problem, you can use this tool, you can do historic lookup, and you can match the timestamps with some of your wired tools and ultimately determine the root cause. Was it wireless or wired? So this kind of gives you that extra pane of glass and that detailed KPI finding. And then some other views. So like table view, give you a quick summary of your devices. And then if you want to do a digger deep, that's where you want to do a data analysis and go per device and figure out what's on the network. And then you can export charts. You can figure out what's going on from a particular timestamp perspective.
Hey, Igor.
Yes.
Excuse me. So we had a slight issue with the link. It was my fault. I had the wrong Slido link in there under the YouTube video. I fixed that now. So if anyone was trying to submit questions and wasn't able to get into the Slido, you should be able to now with the updated passcode. We did actually then get a question after I fixed it here a little bit ago. And the question is Cisco planning a dashboard version of ultra reliable wireless backhaul, or will I need to set up a VM?
I guess right now, today, you're going to have to set up a Docker container to run IW Monitor. There's nothing on the roadmap for a VM or a dashboard, but there will be more information in the coming months about feature enhancements and other updates.
Okay, thanks.
Yep. Okay, so now let's jump into the architecture. So how do you configure these? How do you set the right parameters? So I truly believe ultra reliable wireless backhaul is one of the few techs that can do both static and mobile connectivity well, and I'll show you why in a second. So high level, these are the architectures. So static, so point to multi-point, and mixed, and then your fluidity. So open pit mines, transportation lines, port connectivity, and also oil refinery manufacturing. That's when you're using that fluidity architecture for those moving vehicles. So here is some of the nomenclature that's specific to URWB. So the couple things here are going to be your passphrase. This is kind of like your broadcast shared secret to the other radios, more or less synonymous to a Wi-Fi SSID. Then we have your mesh ID. So this is actually derived from the hardware MAC address, and it's actually used to create the MPLS label switch paths, or LSPs. And then your frequency and channel width, so making sure you're on a common layer 1 setting per RF cluster. Next is going to be the protocol. So we're running Prodigy 2.0, which is MPLS based. And then within Prodigy 2.0, you have radio modes. So the 3 main modes are mesh end. This is typically the radio that's closest to your core that you're extending off to. And think of your mesh end as your MPLS label edge router. So once you go through the mesh end, you're going to be part of the MPLS network, and vice versa. Once you get off of it, you're now connected to your wired Ethernet core. And then mesh point is more or less everything else that isn't a mesh end or a gateway. So your trackside radios, your vehicle radios are typically mesh points. And then last but not least, your gateway, your IEC 6400. This is predominantly used in large fluidity networks that have 5, 10, 40 gigabits of aggregate throughput. You're going to want a dedicated gateway or appliance at your core. And then your radio roles, we have fixed, we have fluid max, primary and secondary. So those are for your static configurations, and then fluidity. And then within fluidity, you have infrastructure and you have vehicle. Those are the two most common roles. So infrastructure is wired to your core and your vehicle is the one that's roaming wirelessly. And then I'm going to showcase the next slides as an AP node. So it's more or less radio agnostic. You can use any one of the products below. So whatever fits better for your application, we're going to put that radio and then configure it to the specifics. So high level, if you want more information about how to configure these, I would highly suggest checking out the software configuration guide in the top right. And then you can see here the static and mobile architectures. Fixed and FluidMax are going to do point-to-point, point-to-multipoint. When you're getting into those more complicated mixed deployments or you have multiple hierarchies or relay points, that's when I like going to FluidMax. You have a lot more nerd knobs to configure with. And then fluidity, traditionally mostly V to I, vehicle to infrastructure in terms of that data flow and handoff. Okay, so let's start with a simple point-to-point. So let's just say you want to extend one Ethernet connection. You're going to identify your mesh end as the radio closest to the core. And then your mesh point is your remote location. So you can see here some common settings, obviously unique IP address, and then common passphrase and frequency to associate and transmit from a layer 1 perspective. So there's a quick and simple example there. Next up is your point-to-multipoint. So if we look at that first example there, you have multiple light poles you want to communicate to. That's when you do fixed or FluidMax. And similarly there, common passphrase and frequency, and then unique addressing from an IP standpoint. And now we get into mixed. So depending on your architecture and how complicated or extended it becomes, you might want to think about using FluidMax primary and secondary. So you might start off with a point-to-point or a point-to-multipoint, but then off of that second or third radio, you want to do another point-to-point, point-to-multipoint. So that's where FluidMax really understands the data flow and can get you from that secondary to primary connection and eventually back to your core where your mesh end is going to sit. So for this example here, we're extending network connectivity from the IT building at Town Hall. And you can see there the frequency planning and the architecture that you would use to configure both radios, uplink and downlink facing, for an example. And then now shifting gears to fluidity. So mobile architectures, fluidity is going to enable that seamless roaming between radios, which is optimal for mobility in our IoT use cases. So when you enable it on the radio, you have to configure it as infrastructure or vehicle. And by default, if you hit that standard handoff mechanism, you're going to enable V to I. So you're always going to have a V to I relationship as you're traversing your route. So it could be a train route, it could be an AGV route in a manufacturing floor, or it could be pervasive coverage at a port or a mine where you have coverage everywhere and you're just handing off as you're traversing the area. And then comes the handoff. So Fluid Mesh CURWB, we have a 0 millisecond handoff with fluidity, and that decision is primarily based off of the RSSI. So you can see here some of the handoff mechanisms in that transition point. So as you're getting closer to an access point, you're going to increase your signal strength. Then you start getting further away, and you're going to have to make a decision as a vehicle. When do I hand off and start forwarding traffic to the better AP? And how we're doing it is with these thresholds that are configurable. So depending on your density and your RF, you can configure your delta high and delta low variables, and also that threshold for when you should start scanning and roaming to that next best access point. And we'll see this shortly in the demo. Okay, so here's the demo I have set up upstairs. So it's a 3 radio fluidity network. So we have 2 infrastructure APs, one configured as mesh end, the other is mesh point, and then your vehicle as a mesh point, roaming and handing off between the 2. So I actually have some variable attenuators set upstairs. So we're kind of going back and forth between these 2 access points. So think of it as a train going between 2 stations, or an AGV going from one route to the other, and just handing off from an RF standpoint. So with that, let me switch gears. me 1 second.
While you're doing that, so just a quick question. So the in this particular demo you're going to do, all radios are configured as fluidity. Is this where like one is the vehicular and one is mobile, or is this?
Yes. Yeah. So we have 2 infrastructure and 1 vehicle. So they're all fluidity.
Yeah.
Yep. So it's
Sorry,
kind of it's a sub role within the architecture.
Perfect. Okay.
Okay, here we go. Okay, so here's me webbing into the mesh end. So I'm going to do the local management, the GUI interface, just to kind of show you the settings. So this is your home page here. You can see we're running IW service in an offline mode. So I do this for my lab since I take it around to customer meetings and whatnot. And we're also connected to IW Monitor, that Docker container on the network. And this is our mesh end. So we'll see later the mesh end enables Quadro in the top left. And then you can see here your general IP settings there. If we click on the wireless radio tab, this is where you set your passphrase. So this has to be common across your clusters. And then also your roles. So back to Al's question, this is where you picked fixed fluid max for static, or in our case, fluidity for that mobile connectivity. And then also your frequency settings. So we're doing 5825, 20 megahertz. And then we're disabling radio 2. So keep in mind you have 2 radios in that 1 hardware. But for simplicity, we're just going to do a single radio fluidity. Next is your antenna alignments and stats. So this is for your installers out in the field. When you're in that bucket truck, you're trying to find that RF sweet spot. So this is kind of a cool tool to look at the RSSI and whether or not you need to tilt up, down, left, or right. So that's a great tool to help you find that signal strength. And then from a fluidity standpoint, so once we enable fluidity, this is where you pick your unit role. So it's either infrastructure or vehicle. So for my lab, we have 2 infrastructure and we're running a flat layer 2, but we can also design for a larger layer 3 network that you see in larger transportation networks. And then handoff logic standard is V to I. And that's more or less the common approach there. Okay, so let's look at Quadro. So Quadro is an on-device topology GUI. It just gives you kind of a live look at the network. And this can only be found on the mesh end. So if you go into the mesh point, you're not going to see Quadro, but if you web into the mesh end, you'll get the Quadro interface. You'll get a bunch of cool RF stats, uplink, downlink, RSSI, MCS rate. And then you can see here the RSSI, you can see the attenuation kit in action. So we're starting to attenuate and come to that handoff decision. So you'll see here in a few seconds going from node 1 to node 2. And now you're riding radio 2 because it has a better RF envelope. And we're going to be doing this back and forth throughout the duration of the lab. And then next up is monitor. So we're connected. We got the Docker container up and running. And if you get to this page, this is a good indicator that it's running. So you're going to log in. Right now it's on .100, my IP address here. And this is kind of your dashboard view. So it kind of gives you a quick holistic view of what's going on. And then you can kind of drill into the table view. So you can see all the configurations for the 3 radio nodes that we have here. You can see the role we're in, radio 2 is disabled. And then you can see more information about the throughput, MCS rate, link error, packet error. Right now, we're kind of in idle state. We're not pushing traffic, but you can see some of the KPIs we're able to gather from this tool. And then digging in deeper. So if you want to dig in, go to data analysis. And in our case, we're looking at the vehicle perspective. So he's going to see both trackside infrastructure and also the uplink, downlink throughput, link error, packet error, and then your MCS rates and MIMO states. So you'll kind of get a quick summary there of all the different states on the network. And also you can look it up because this is more or less a database that lives on the Docker container. So you can see there, we're hitting our threshold, that 6 dB delta, and we're going from one AP to the other. And then last but not least, that topology view in monitor. So similarly to Quadro on the mesh end, you can hit the topology tab here and monitor and get that same look and feel that you get from a Quadro. So to me, this is really insightful information because you're not going to really get this from an SNMP. And it's very RF rich in terms of the KPIs. So you can really dig in, drill in to see what's going on and how to modify or tweak the network. So you might have high interference or maybe a disconnected antenna. And once you have one of those layer 1 failures, you can easily identify and then go fix the problem at the site.
So just so I'm clear on this, you're actually connected to two different, your infrastructure connected to two different your vehicle's connected to two different infrastructure access points at the same time, right? So you're showing it moving, but really it's just the data flow that's moving, or it's actual connection, RF connection that's changing?
So the vehicle radio is always aware of the other radios, but we're actively only transmitting to one AP. Unless you enable, yep.
Okay.
Unless you enable something like multipath operation, where you're sending the same frame over two independent RF streams. And that's where you can kind of build up the redundancy. So this was kind of a simple single channel fluidity lab showing you the make before break, the delta thresholds. But we can definitely build upon it and do a multi-frequency deployment. Especially now with our radios, we have two radios in that one IW package. So it's going to be easier to configure and manage those devices versus the legacy fluid mesh gear we used to sell.
Gotcha. Thank you.
We do have a few questions here, Igor, that came in, and two of these I'll group together. I think they're somewhat forward-looking, but I think we do have some exciting news here to in the future. I'm not sure what we can share, but one of them is, I was told Cisco Live, 6 gigahertz is not supported on CURWB. Will this come to existing radios, or will it only be for new hardware? And the other question is, any plans to bring CURWB to indoor APs? Appreciate the need for doing this on outdoor APs for backhaul. But I also have indoor warehouse applications and do not require IP67 APs.
Okay. Let's start with the FM question. So legacy FM hardware, that chipset was more or less tuned from 4.9 to 5.9 gigahertz.
Sure.
So those unfortunately are not 6 gigahertz capable.
Yep.
Whereas the 9160 series, the IWs, those are 6 gigahertz ready, but CURWB currently runs on 5 gigahertz. And that's something our product management team is actively working on to figure out the caveats and the mechanism to enable 6 gigahertz.
Sure.
And I can't say anything today, but in a few months, we're going to have some big announcements that'll help CURWB converge with the standard Cisco wireless portfolio. And I think once that convergence happens, we're going to unlock some of these other features like potentially 6 gigahertz and also that AFC coordination on the back end.
Yeah, that's great news. I think one thing you've seen, or our viewers have seen, is kind of the unification of the Cisco platforms and hardware and simplifying. So, I guess stay tuned for more on that. And then the other question that came in a little while ago was, can you help me understand the difference between CURWB and Meraki mesh, when to use one versus the other? And I know we covered this more in detail on episode 15. I think we had a detailed chart on this and stuff. So maybe a summary here, just a kind of quick answer, and then we can also, refer them back to episode 15 on the channel as well.
Okay. High level, CURWB is a more engineered wireless backhaul solution. So we're using more directive antennas. And we try to mitigate meshing, because as you're meshing, you're increasing latency and you're halving your throughput, because you can only transmit or receive off a radio. So from a network KPI perspective, you're going to get higher throughput, lower latency, and longer reach because you're using a more directive antenna. And also we have a lot more parameters we can fine tune from an RF standpoint. So we can really support those mission critical applications. We can add on QoS and send smaller frames more often. So there's just a lot more variables we can tweak to make sure your application is running smoothly and wire-like.
That sounds good. Cool. Thanks.
So if we got a second, real quick, I have a question. Just dealing with the manufacturing situation where we have autonomous vehicles on a manufacturing floor, when would I use ultra wireless backhaul versus when I would use just say a workgroup bridge in traditional Wi-Fi? I mean, what sort of decision points do you think about when you look at what technology you use?
Sure. It's a great question. It more or less, I like to think of it as like mission criticality. So ask yourself, can your application handle a wireless disconnect? So if you're looking at PLCs, your RPI, your heartbeats, if they're very stringent and wire-like, and I'm thinking of less than 100 milliseconds, that's when you might have some problems with workgroup bridging or Wi-Fi, because workgroup bridging isn't a make before break, it's a break and then make. So you have a small window where you have a disconnect. And there's ways to mitigate that with .11r and doing dual radio workgroup bridging. But ultimately, CURWB is going to have that 0 millisecond handoff. And also you can do MPO and other cool RF things to kind of enhance that reliability number. So those are kind of the questions I ask. And then also asking the question to the manufacturer is like, how much money are you losing with downtime? And if it's something that is making it hard for them to sleep at night, then I would say lean towards CURWB and kind of help mask some of the network or PLC configurations that we can or cannot change. But that's just more or less my high level answer there. There's a few other variables in play, but I just say mission criticality, CURWB. If you want best effort, workgroup bridge is good enough.
That's great feedback. It's great feedback. All right. Anything else, Dan, that Igor?
I don't see any other questions. Yeah, Igor, do you have anything else?
That's more or less what I have for today. I'm kind of keeping the rest for part 2. So
yeah, I'm excited for part 2.
Yeah, you stole the words out of my mouth. That's what I was going to say. I think we're all excited for part 2. So that's great. Yeah, please tune back in here in 2 weeks, and we will have the exciting conclusion here, part 2. But until then, I want to thank you, Igor and Al. Great content here. Igor, appreciate your time and expertise on here. I think it was really good. Sorry about the Slido questions there to our viewers. I did get it up and running. We'll fix that going forward. But we just tried to change the passcode to make it more simple. There were some ambiguous letters in the passcode that people weren't sure if it was a L or a 1 or whatever. So we tried to simplify that and didn't update something on our end here on the link. So thanks for that. I don't see any other questions right now. So thanks again. Tune in next time for episode 2. As a reminder, you can find this and all the other great content out on youtube.com/@getunplugged. Go out there, subscribe, and you'll be notified when we do post and go live with episode 50, believe it or not, which is part 2 of this series. And then if you do have questions, you can always reach us via your account team, your Cisco account team. You can email us directly at getunplugged@cisco.com. You can DM us on Twitter at X at Unplugged80211 or on Threads, Unplugged Connectivity. So thanks again to everyone for watching. Thanks, Igor. Appreciate your time. And until next time, stay connected and unplugged.